So I've soldered up these kind of really ridiculous adapters here. These are just a very temporary measure. What they're doing is breaking out the power rails coming into the system to jumper leads that I can hook into this temporary switching power supply. This supply is plus 5, plus 12 and minus 12. It's rated 66 watts, I believe. Very similar to the original power supply. You know, basically the same rating as this supply in a smaller form factor. And I'm debating whether to replace this supply with a couple of more modern ones. Looking at this supply at the same time, the capacitors are Nishikon, the green ones and the large black ones, and I haven't been able to get a view onto the blue ones yet. No, they're all Nishikon, so all the larger caps are Nishikon, so they're high quality caps. So this was probably a high quality power supply back in the day. So I think it's well worth troubleshooting and probably using. But you know, I've got this switcher here, and I'd like to go ahead and just give the system a quick test. So what I've done for incoming AC power is this connector here, and it's got the neutral on this side and the brown is the line. And the brown wire comes to line on the switcher. The neutral comes over to the neutral on this switcher. The chassis ground is connected to the system ground, so that the earth ground reference is common all the way through. And what I should be able to do here is click the power on, have that supply come up. I can measure the voltages and not have like wires melt down here because I've got things swapped and I've created a short, blow a circuit breaker out. So hopefully this should just come up and not cause any problems. You find the power switch. That's a good sign. We've got 111 volts DC. That doesn't make any sense. Millivolts. Okay, something's not making sense. Oh, it's because the common isn't connected. Yes, that would make sense. So let me go ahead and switch the power off. I actually do need to connect the commons up to the common here because the outputs on this are floating. We need to get everything to a common reference, and that means hooking up the common of the machine. Oh, if I can get that to trim off there. Like I said, this adapter cable is very temporary. It's really just kind of meant to allow me to do this kind of testing here. So that now should make the common on the output of the power supply. Let's go to ohms for a minute. And we should now see continuity. And we do. So that's got the power. So that's got the commons referenced together. The meter commons over here. So back to volts DC. I should now measure 5 volts here, assuming nothing pops, which it shouldn't. Where's the switch? That's reset. That's reset again. Why can't I find the power switch? There it is. 5.06 volts. That's what I expected. Plus 12 here. I expect minus 12 here. Perfect. So all of that looks absolutely correct. So that's a really good sign. Let's see. I need to hook the browns together. So this is also a neutral reference. So the purple and brown here are for the monitor. They produced the 12 volts to it. On the original supply, it was a separate output, so that as the disk drive head stepped, etc., it wouldn't cause the video to kind of flash or to move around as the power supply rails bopped up and down. For this test, I'm just going to make these common. I don't really have two isolated 12 volt outputs here. Of course, this assumes I can get that to go in there, and that looks like it's going to be more of a challenge than it should be, and I'm not sure why. What the heck? There you go. And the purple here will pick up plus 12. And again, I have compared this extensively to this edge connector, and common for the monitor is on the outside pin, and V2, which is plus 12, it'd be on the purple one here. So I spent a lot of time validating this is correct. So we can pick up plus 12 right here, and this should just power up the monitor and nothing else. And hopefully what we'll see here is plus 12 on the meter, and after a moment we may see the heater and the CRT come on, and hopefully I'll be able to see a raster. The way it's kind of positioned, it'd be hard to see, but we'll see what we get. So hopefully, I heard the high voltage come up, and there's the heater and the CRT. So we're good. I heard the high voltage come up. I can see there's actually a glow off the CRT up under the bench. It's nice and bright. There's a couple of pots here. Bringing the brightness down, it definitely reacts to it. So that's excellent. That's exactly what we wanted to see. So really now it's just getting the other 3 voltage rails hooked up. I should have stripped these before I soldered this together, rather than leave it for this point. Yellow in this case is minus 12. I know that kind of flies in the face of modern color schemes. Dropped the screwdriver and cannot manage to pick it back up. So yellow does go to the minus 12. We need to take the orange, which is plus 12. The orange, looking at like the floppy power supply connector, we can see it's got an orange wire coming to it. You can't see it, but we do. So it's going to share the plus 12 rail with the monitor. Plus 5. This is a silicone lead. It's a little bit harder. Oh, I guess it's not a little bit harder. You can see these are all just scrap wires that came off the bench. Oh, shoot. And of course, right under the neck board of the CRT. Of course, that's where it fell. As you know, the last thing I want to do is bust the neck off the CRT. That would just be an absolute friggin' nightmare. So the red is plus 12. It's coming to plus 5. I mean, the red is plus 5 to plus 5. The yellow is negative 12. The orange is plus 12. There's 3 pins in the connector. The orange goes 2, 3 pins. The red goes 2, 3 pins. The brown goes 2. And only 1 pin the minus 12 goes to, since it doesn't draw near as much current. So I wish I could see the CRT. But for now, we'll just fire it up. Maybe we'll hear the floppy drive do something. Yes. That's a good sign. I can hear the motor running on the floppies. So it's looking for boot media. So at this point, can I rotate this around so I can actually see the CRT and get an idea if we're getting video? I think I probably can. I just got to be a little bit careful here. think I will rotate it 90 degrees this way. The keyboard being permanently attached is a bit of a challenge. But at this point I can see the CRT, I can see the floppy drives. We can put system or AC power back in. Don't really need the voltmeter at this point. And I know you can't see the screen here, but I'm going to go ahead and apply system power. That's reset. I have a raster. Ah, yes. The floppy disk drive is not ready. Diskette. Wow, it's got English, German, and I'll get a picture of what the screen looks like. It's not a green screen. I'm kind of disappointed. I assumed it was going to be a green screen monitor. This is really a really good sign, which means this is going to be a simple fix, assuming that it'll be simple to fix that switching power supply. With it accessing the floppy with me getting video, this all looks really good. Which in some ways is kind of disappointing. I was hoping there'd be more to troubleshoot. But it is what it is. I will be, supposedly if it doesn't have 128K of RAM in it, I will add the 8 additional 64K DRAMs. There's a CPU overclock module available from a guy in Australia. I will probably order that, and it'll get at a 6.1, I think, megahertz Z80 variant processor. And if it doesn't have the graphics card installed, I can get a third-party graphics card to get what they call the high-res graphics on it, which in today's world aren't all that high-res, but it would still be nice. So let's get the power on. Give it a minute to wake up here. Here it is, accessing the floppy. And actual video. The floppy disk is not ready, which it's not. Disketten. Laufwerk, niche. I can't pronounce it. It almost looks like, I mean, the second one looks like German to me. And that one almost reads like French. But I don't know. Anyhow, pretty cool. Pretty cool. So, see you in the next video.